Now we'll study about calculating equivalent capacitance in circuits using nodal analysis. We already discussed about calculation of equivalent capacitance by use of series and parallel combinations. Here we use nodal analysis, and for complicated circuits it will always be easier to use this technique. I just demonstrate the same with the help of a simple example. Here, say we are given with three capacitors connected in this fashion, where two are in parallel and one is connected in series across terminals A and B. Say there's 2 microfarad, there's 4 microfarad, and there's 8 microfarad capacitor. If I wish to calculate the equivalent capacitance, I can easily calculate by taking 4 and 8 to be in parallel and then in series with 2 microfarad. But I am not going to use this series parallel analysis. I'll solve it by using nodal analysis. And for this, there are two things you need to keep in mind. The very first is for calculation of equivalent capacitance of a capacitive circuit, always use a 100-volt battery across the combination. Here we connect a 100-volt battery across this circuit, because whichever battery I'll connect, it won't affect the equivalent capacitance. So I'll use a battery which will be allowing in calculations. That's why I'm using 100-volt battery. Now in this situation, once I've connected the battery, I'll try to calculate, due to connection of this battery, how much amount of charge will flow through this battery. Say if I'm having a switch, and if I close down the switch, say a charge delta Q is flown through the battery from one side to another. Then in this situation, I can directly state that on measurement of charge flowing through battery, this is the next step, and say if it is delta Q, then we can directly write the equivalent capacitance will be delta Q by 100. As we know, if there is a battery connected across the circuit, then the equivalent capacitance will behave in such a way that the total amount of charge it is acquiring is C equivalent multiplied by the battery voltage. So your equivalent capacitance will be delta Q by 100. And to calculate the value of delta Q, here we can find out charge is flowing from this side to this. So here these two plates of capacitors are connected with the battery through which charge is being transported, or it is supplied to this plate. So either we can calculate the charge of this plate or the sum of these two plates in magnitude. So to calculate it, we use nodal analysis, and here we distribute the potential. In the circuit, here on negative side we consider say 0, then with this reference the potential on the other side would be 100 volts. And at this node I consider potential at X. So I can write down the equation for X, as there are three plates connected with this node. So sum of the charges of these three plates must be 0. So here charge will be 4x plus here charge will be 8x plus on this plate charge will be 2 multiplied by x minus 100, and it should be equal to 0. On further simplifying this, we are getting 6x plus x minus 100 is 0. So here x we are getting as 100 by 7 volt. So we are getting the value of x. The amount of charge delta Q I can write as the sum of the charges on these two capacitors. So this will be 4x plus 8x, that will be equals to 12x. So here I can write the value of C equivalent as 12x by 100, where I can substitute the value of x as 100 by 7. So this will be 12 by 100 multiplied by 100 by 7, which will result 12 by 7, and units would be microfarad. That will be the answer to this problem. Here you can verify the result by using series parallel analysis also. And many students feel that there is quite a lengthy procedure to obtain the result, as by using series parallel we can directly calculate it. But you'll see, and surprisingly you'll see that in so many cases when the circuit is complex, will not be able to use series parallel analysis because none of the given capacitors would be in series or in parallel, where this method will help us a lot in quickly getting the result. Gradually you'll see in various different kind of problems where we are going to use nodal analysis.